Hello and welcome. This is a lesson on weather fronts. Get ready to learn. Oh my goodness, we have a lot going on in here. We're going to figure some of this out. Did you know the air on our planet heats unevenly? It heats differently over water than it does over land. Air masses move from the poles to the equator. So we have a general air flow from the poles towards the equator. A front happens when two different air masses meet. We have high air masses, or high pressure masses and low pressure masses. When they meet, you have something called a front, and that's where a lot of weather happens. Most storms happen when a high and low pressure meet. That's where this line is drawn. So, let's dig a little deeper. What's important to know about weather fronts? Well, knowing how the air moves helps us forecast the weather. Okay, this is a winter outlook, and this is a forecast for an entire winter. Of course, the further out you get, the less accurate you are, but this is not looking at what's going to be tomorrow. It's going to be what's going to be in a general way for precipitation. So, what's important to know about weather fronts? Air is heated faster over land. Air is heated slower over water. So you have land heating up fast, water taking longer. The pressure balancing causes wind. So if you're heating the land, the air right over the land is going to expand and be lower pressure being forced up. Air over water is not going to heat as fast, so it would be higher pressure, higher density, and the balancing of the high pressure here and the low pressure here, and the high pressure here and the low pressure here, causes wind as the cool air travels towards the warmer air over the land. That's where wind comes from. Now, we have some general global wind patterns. They're usually from the poles to the equator. They come from the poles, both the North and the South Pole, towards the equator. And we have different names for these because they're in a general pattern here. Local heating causes local weather. That's why day to day it changes. But in a general area, if you have desert, you're going to have similar weather all the time, even though you might have little spots of different weather. And the jet stream pushes the air masses. This is at the top of the troposphere. There's a river of air that meanders around the planet. Okay, let's talk about warm fronts and cold fronts. They're named after the temperature of the air mass. So you have warm fronts, warm air, cold fronts, cold air. That just makes sense. Cold fronts usually move faster than warm fronts. There's more air molecules there, so there's more moving. Cold fronts are higher pressure, more density. And the warm fronts have lower pressure. So you have differences in temperature and pressure. Cold fronts move faster. Cold fronts have higher pressure. Warm fronts have lower pressure. Okay, here's a warm front on the map. This is the direction of the movement. If these lumps were on the other side, it'd be going the other way. It would indicate it was going the other way. So these are the direction that it's moving, and that's on a map. Now, here's what it looks like on the planet. Advancing warm air behind a warm front. Cloud development because of frontal lifting of the warm, moist air. And then if the warm air front is pushing the cold air out, it's doing it slowly, and the colder air is more dense. So it's more like a ramp that it's sliding up. So the warm front is named after the temperature. Warm fronts are lower pressure and higher humidity, so it's going to be less dense with humid air. Air is warmer after the front passes. If you were standing right here, let's draw you. There you go. If you're standing there and this front now passes and is here, you went from being in cooler air to warmer air. So air is warmer after the front passes through. Now let's look at a cold front moving through. And you can see on a map, direction of the movement is with these arrows, cold front map symbol. So it's going in this direction. The advancing cold air behind a cold front is pushing the warm, moist air up, and it's doing it faster. Remember, cold air fronts move faster than warm air fronts. And because of that, it's shooting the moist, warm air up, cooling it down and causing cloud development. So cold fronts, they're named after the temperature of the air mass, remember. They usually move faster than warm fronts and are of higher pressure. And higher pressure air will lift lower pressure air because it's more dense than the lower pressure air. So, we have stationary fronts. Two fronts meet and don't mix. We have a couple of them in this map. Two fronts meet and don't move. They are stationary. So we have one here. See it? Red, blue. We have another here. They're meeting and they're not moving. The weather lasts for days. If it's not moving, it's staying still. So the weather stays the same. Usually some kind of precipitation. Because remember, precipitation happens when fronts meet. There's a stationary front. Here's another one. Okay, we have different storm names. We have hurricanes, cyclones, typhoons. They're all the same. Hurricanes are generally in the Atlantic. They have a season. They're from June to November. Cyclones are generally in the South Pacific and the Indian Ocean. And typhoons are generally in the Northwest Pacific. So it's just, they're all the same. The genesis, where they come from. They all start as a tropical storm over warm water. The label changes from a tropical storm to a hurricane when there are 74-mile-an-hour winds. Now the direction. They're counterclockwise in the northern hemisphere. They go this way in the northern hemisphere and clockwise in the southern hemisphere. And a different direction is due to the Earth's rotation, and we call this the Coriolis effect. Because the Earth is spinning like a top, it does affect the way that the storms form. So in the northern hemisphere, they are counterclockwise, and in the southern hemisphere, they are clockwise, and you can see that they're reversed. So what is important to know about weather fronts? We have different storm types. We have tornadoes. They're usually formed over land, which is different. They're usually very local, small, local disturbances, maybe a mile wide instead of hundreds of miles. Here's a tornado. This is a map that shows where tornadoes form. You can see there's a band of the United States that has more instances of tornadoes than other places. So, why is it important to know about weather fronts? Knowing how the air moves help us forecast the weather. It's not easy, but we're doing a good job of it. There's your lesson on weather fronts.